The sum S sub n is equal to n times the quantity a1 plus an divided by 2, where the value of n comes from. Subtract a sub n minus a sub 1. Then divide the result by d. Plus 1. Alright, let's take a look at a typical example of a problem right here. If we sum up 1 plus 2 plus 3 and so on, continuing all the way up to 100, where we will find d, and d is defined as being the common difference. D is equal to 1. D is calculated as 2 minus 1, which is 1, and 3 minus 2, which is also 1. So it's a consistent and constant interval, meaning d equals 1. And now, the starting term of the sequence is a 1, and the end term is an n. So we get the sum Sn equals n times the quantity a1 plus an, all divided by 2. Now we see that n has exactly 100 terms ranging from 1 to 100. So n will be 100. Here, a1 is the first term of the sequence, which is simply 1 plus an. An is the last term. This is an. And that's 100, and all of it over 2. Dividing 100 by 2 gives us a final result of 50. Next, multiplying 50 by 101 will result in a grand total of 5,050. 5,050 in total.
Let's solve a NetSat problem from year 67. Given tangent theta equals -4/3 for theta between 0 and 180, find sine theta plus cosine theta. First step, we're going to draw a diagram. And then we'll add the angles. The problem says theta is greater than 0 degrees, which is shown right here, but is less than 180 degrees. But in this case, the value is negative, so it'll be in the second quadrant. Here it is. This is the diagram we get. Once we have finished drawing, we will be able to see exactly what sine theta is equal to. Sine theta is opposite over hypotenuse, so it's 4/5. Given that cosine theta equals -3 divided by 5, then we will find the value of the sum of sine theta and cosine theta. So we have the sum of 4/5 plus -3/5, which is going to be equal to, it's 1/5. This is the answer for this problem. So it's option A.
The problem gives, we are given the frequency, which is f, and the problem also gives us the wavelength, which is lambda. The problem asks for the speed is v. Use the formula v equals the frequency f multiplied by lambda is equal to 400. The value is currently in centimeters, so we have to convert it to meters. Multiply 1,050. The unit is, it is measured in meters per second. Alright then, this is all of part A. Now we are going to locate part B, and part B is over here. The problem wants to find T. The problem gives S. V equals S over T. Bring it down now. The value of T is equal to distance over velocity. Distance is equal to 300 and velocity is 50. That equals exactly 6 seconds in total. Completed.
Okay. Today we're going to work on this problem here. For this problem, we'll use these definitions. First, a to the power of n times a to the power of m equals a to the power of n plus m. The second one is a to the power of n all raised to the power of m, which equals a to the power of n times m. And then the third one is a to the power of n divided by a to the power of m, which equals a to the power of n minus m. Okay, let's go ahead and solve this one. For this one, we distribute the exponent first. So it's to the power of 30n times a to the power of 40n all over a to the power of 3n. That equals, now we're going to combine these terms together. It'll be to the power of 40 plus 30, which gives us a total of 70n divided by a to the power of 3n. Then we bring that denominator up, so it becomes a to the power of 70n minus 3n. And finally, that equals a to the power of 67n. That's it.